We are all these subatomic particles broken up into leptons, bosons, hadrons, and quarks and fulls. We are the parts that make up each and every atom. So let's learn about us and try to have fun. We are the leptons, count us and you will find 4. We do not experience the strong nuclear force, but we do interact through the weak nuclear force, electromagnetic force, and gravity, of course. As fundamental particles, we form the building blocks of matter. That's what we vlog. The first generation of leptons are responsible for most stable matter in the universe, while heavier ones quickly decay. That's something we told you in our verse. You should know me already. I am an electron. I maintain an atom's electrical neutrality. Isn't that fun? As well as conduct electricity and form chemical bonds by being shared or transferred between atoms. You see, our arrangement and movement determine the chemical properties of an element and drive chemical reactions. I am the positron. I am also called an anti-electron. I am an antimatter particle that annihilates with electrons, releasing energy in the form of gamma rays. That isn't fun. I am used in medical imaging, and I track metabolic activity in the body. I'm also used in particle physics research, where we are collided with electrons to produce high energy events and study fundamental particles. I am the next lepton, and I am called a muon. I have several practical applications. I am created when cosmic rays hit the Earth's atmosphere, and due to their unique properties, here's what you're about to hear. We can be used for muon tomography to image the insides of large objects like pyramids and nuclear reactors, and to help study fundamental particles. You see, we are also unstable with a lifespan of only 2.2 microseconds, and our decay is used in experiments, I reckon, to study the weak force and the properties of matter. I'm the final lepton, and I am called a neutrino. To me, you better not say no! Please be nice to the audience. I don't think they want to hear you screaming and yelling. Okay, stop bossing me around already. I'm the final lepton, and I am called a neutrino. I'm sorry for what I did earlier, you know. Anyway, I travel through matter with very little interaction, allowing me to act as a messenger from extreme cosmic events like supernovae. This gives the story traction. We are the 4 bosons. You might be wondering what we are in this song. We act as force carriers in the universe, transmitting forces between other particles, like the fundamental particles of matter. We are also responsible for phenomena like mass. That is something we tell you in this class. In this song, I'm going to be the first boson, and I am called a photon. I am the smallest possible particle of electromagnetic energy, and therefore also the smallest possible particle of light. As you can see, I can travel at the speed of light because I have no mass, I have no charge. This is something I taught you in my class. It takes at least 1 quintillion years for a photon to decay. Since I have such a long time left, I gotta say hooray! I am the Z boson and I mediate the weak force, and I am responsible for neutral current interactions, of course, where I transfer energy, momentum, and spin between particles without changing their flavor change within. I am a massive neutral particle that can decay into pairs of leptons like electron, positron, or quarks. Now let's get to work. I'm the W boson and I am a lot like the Z boson. We are both responsible for the weak force, one of four fundamental forces that govern the behavior of matter in our universe. Particles of matter can interact by exchanging these bosons, but only over short distances. This was a long verse. We W and Z bosons have a half-life of only 1/30th of a octosecond. That's extremely short, you see. I'm the last boson we're going to talk about, and my name is the Higgs boson. My primary role is to give fundamental particles mass. Through their interaction with the Higgs field, give fundamental particles mass. Through the interaction with the Higgs field, this is something I tell you in my class. Particles that interact with the Higgs field become sticky, gaining inertia and mass. Isn't that tricky? While particles that don't interact, like photons, remain massless. This is something I told you on. I have a lifespan of only 180 octoseconds. Since I'm so unstable, I live such a short life. That's something I reckon. We are the next class of subatomic particles. We are called hadrons. That's something we tell you in full. We are built from quarks and thus react through the energy of the strong force. We are the baryons and we are made up of three quarks. Let's learn about us. Let's get to work. I am the really well-known proton. I determine an atom's elemental identity by their number. I give the atom a positive charge. I attract negative electrons to keep the atom together at large. We are positively charged particles found in the nucleus of an atom, and the number of protons an atom has is its atomic number, which is unique to each element for sure. I am a neutron and I stabilize atomic nuclei by binding with protons, preventing them from repelling each other due to their positive charges. And neutrons have neutral charges. While the number of protons defines an element, the number of neutrons determines the specific isotope. That's what I meant. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons and 8 neutrons. We are mesons and we act as carriers of the strong nuclear force, holding protons and neutrons together in an atomic nucleus, of course. We are fundamental to understanding particle interactions and are used in both scientific research and practical applications. 2 or more quarks can be found in us. Now let's learn about the mesons without a fuss. I am the pi meson, but please call me the pion. I contain 1 quark and 1 antiquark, and I count for most of the mass in atomic nuclei. More importantly, now listen to why. Pions are responsible for the residual strong nuclear force between protons and neutrons, in turn making it possible for nuclei to exist at all. Of course, I have a lifetime of about 26 nanoseconds. That's a lot longer than a Higgs boson, I do reckon. I am a K meson, but call me a kaon. I am a composite particle composed of strange quark and an up and down quark. Let's keep talking about me, so we do not stop our work. I am a type of neutral meson characterized by my unique quantum mechanical properties, including interference effects and decays, and the phenomenon of two-facedness, hooray, which allows for realizations of thought experiments, such as the Einstein-Podolsky-Rosen experiment. We are the 6 different types of quarks, and we combine with each other through the strong nuclear force to form the hadrons. You already met them, so let's just keep moving on. I am the up quark and my symbol is U. I am the least massive of the quarks. That's something I had to tell you. I form protons and neutrons. I provide positive charge to protons, enabling atoms to exist. Now let's move on. I am the down quark, and my symbol is D. I'm the second least massive of the quarks, as you can plainly see. I partner to the up quark in nucleons. I'm responsible for the neutron's neutral charge. Let's keep moving on. I enable beta decay from a neutron to a proton. Now let's move on to meet the strange quark. He is extremely fun. I am the strange quark, and my symbol is yes. I am the third least massive of all the quarks, yes. I am found in exotic particles like kaons and hyperons. I'm important in high energy physics and neutron star matter. Let's move on.
I am the charm quark, and my symbol is C. I'm the third most massive of all the quarks, as you can plainly see. I create heavier mesons like D mesons. I help probe weak interactions and CP violation.
I am the bottom quark, and my symbol is B. I am the second most massive of all the quarks, as you can plainly see. I am found in B mesons. I'm crucial for studying matter, antimatter, asymmetry in the universe. How fun. My symbol is T, and I am the top quark. I am the heaviest quark discovered in 1995. I do not form hadrons because I decay too quickly. So that makes me wanna cry very badly. Wah! 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 Stop.
Okay. I'm gonna start over.
My symbol is T, and I am the top quark. I am the heaviest quark discovered in 1995. I do not form hadrons because I decay too quickly. I have a lifetime that only lasts 500 rontoseconds, as you can plainly see. Maybe there are even heavier quarks than me, but we just haven't discovered them yet. Let's sing the chorus. We are all of these subatomic particles broken up into leptons, bosons, hadrons, and quarks in full. We are the parts that make up each and every atom, so we hope you learned a lot and you had fun. We are all of these subatomic particles broken up into leptons, bosons, hadrons, and quarks in full. We are the parts that make up each and every atom, so we hope you learned a lot and you had fun. We are all of these subatomic particles broken up into leptons, bosons, hadrons, and quarks in full. We are the parts that make up each and every atom, so we hope you learned a lot and you had fun.
Hey you, subscribe. But wait, if you subscribe in the next 10 seconds, you will receive a cookie in the mail.
They kicked me out of the music video. They said that my shape was too weird compared to all the other subatomic particles. You know what? I'm just gonna make them add me. I'm gonna march right up to them and tell them, you guys are gonna add me in the video, whether you guys like it or not.